Hold on a second. Good evening. How are you, Ethan? And Nada?
Doing all right. You?
You guys are doing good, man. I like what I see on the homework. I like what I see. I love it.
The time is not on still though.
Yeah, that's fine. They don't. It never had one.
Oh, okay. I'm trying to keep
Never
my
really
days for
had
these
one
things
for
so I
homework.
can.
But on the quiz, on the
Hmm.
exam, you're gonna have one.
Yeah,
So the pressure's on.
yeah.
You know. So keep that in mind when it's like when you know you got to figure it out real fast. That's when you start making mistakes, and you have to have your game on. But it's good that you know at least you have an idea.
I try to do it over in the study plan like one more time so I can get a feel for it.
Yeah, yeah, no, it's a good thing. It's a great thing.
So real quick with chapter one, the focus, well, besides known definitions, is like trying to get those taxes right for the S&C corporations.
Say that one more time.
So the focus for chapter one, that's like definitions, and then we got to focus on taxing the uh, share price correctly between the S&C
We're
portion.
not going to have too many questions from chapter one.
Okay.
A few, but nothing, nothing about calculating stocks. And you're not going to get to that. That's going to be coming up, right? That's going to be coming up. But we're not going to really calculate on, like basic stuff like that. No. When we get to shares, and we're going to get to that. The class is basically what I like to call it. It's like a almost like a boot camp for learning business because we touch on everything. So meaning that if you wanted to work for a dealership, if you wanted to work for a mortgage company, or all these different types of businesses, calculate bonds. I've had when I worked at the bank, I've had people who came from schools, real um, I would say elite schools, and they didn't know how to, and they were business majors, and they didn't know how to calculate a bond. You're going to know that when you're done with this class, right? You're going to know how to calculate a lease for a car, right? And now you're doing perpetuities and annuities and stuff like that. There's only what you're learning is the real world, the real thing, right? And we did a conversion with currencies, right? That's real. That really happens. Those are real things that really happen, right? You go work for a firm, and you yourself, you smart guy, they tell you, okay, um, we're going to be dealing with different kinds of currencies. Hey, Stephen, you're going to be dealing with different kind of currencies, and how do I calculate this? And should we do this deal? Those are the kind of things that you're going to be presented with. And we better do it fast because currency loses value on both sides, right? So those are real things. Those are real things. That's what makes this class so good, right? Real things that we're learning. The mortgages and all that stuff. Those things really happen, and how to calculate one. But you're doing good. Just keep up the good work. All right, we're going to start in about 8:05, 8:06. We're going to go over the homework. And when we go over the homework, um, any questions? Some of you did really well because you took your time in doing it, and some didn't. So we have to go over the whole thing. And on the quiz, there are a couple of questions there that I must go over with you because I know that you don't know how to do it, and I don't like to send you to war without you being equipped for it. All right? So just wait a couple of minutes, let everybody come in. So I don't want to repeat myself. How you doing?
I'm good, Professor. How about you?
All right.
This chapter 4 is very difficult. Uh, Believe me, I find it very difficult up till now as compared to the rest of the chapters.
Oh, really? Okay,
Yeah.
well, we're going to go over it. And let's start now because what? Oh, God. Okay, let's go over it. Let me open it up and we're going to go over it. One of the things that has to be understood is that as I'm teaching it, right, you have to take notes and you also have to be aware of what is being asked, right? What's going on. So this situation, it says you have a loan outstanding. It requires making 8 annual payments of $9,000 each at the end of the next 8 years. Your bank has offered to allow you to skip making the next 7 payments in lieu of making one large payment at the end of the loan terms in 8 years, right? If the interest rate on the loan is 1%, what is the final payment will the bank require you to make so that it's indifferent to the two forms of payment, right? So what this is saying, this is telling you that you can do this two ways, right? The bank is saying instead of paying me each year, right, this amount of $9,000 at 1%, you can defer it, and pay me 9 grand, right, times 8, right, 8 times 9, right, at the end. Now, I told you before, I was explaining to the class that this is a finance class, and sometimes these kinds of financial structures, right, are used in different things. Like athletes sometimes defer their salaries, right? They defer it until they're done playing, right? They get a small portion of it, like so they don't squander the money away. You can do this. This is almost like the same thing, right? This is almost like the same thing. If you say a loan, you could say this, they owe the athlete, right? Almost the same thing. Almost the same thing. But here, it's with a bank. And usually, a bank doing this with someone is very rare, but it can happen based on this person's financial ability, because there's no way that the bank is going to defer $9,000 and they're not sure if they're going to get it in 8 years. So this is what we're going to do. This is how you calculate this, right? The number of periods is 8, right? The interest is 1%, okay? The payment is 9,000. The payment is 9,000, right? Present value, that's not what you want to know. So present value equals 0, and you compute for future value, right? Because remember, you're paying the 9,000 at a future price if you do it each year, right? How much is that money plus interest? That's what you're going to be paying, right? So this one right here, it's saying that we can wait. We can wait, and the calculator does the compounding for you. So that's the answer that you're going to be getting. So what answer did you get?
74,571.
Good. Good. All right, do you understand what's going on here?
Yes.
All right. Does everybody understand? Does everybody need me to go over anything? Everybody got this?
Yes, I got this one.
Okay. Because I saw some emails going, anyway. All right. So let's move on. Okay. So this is yes? I can't see that.
She said yes.
Okay. 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 So this happens all the time. Queens College, right, wants somebody very wealthy, wants to endow, right, a scholarship funds where we will receive $14,000 forever, right? And what has to happen is she has to know, or he has to know, how much money they need to put in the bank to receive $14,000, right, forever. So what we do here, we use the perpetuity formula, right, which is 14,000 cash divided by rate. So 14,000 divided by 0.08, right? And that's how we calculate this. So what's the answer there? 14,000 times
175,000.
how much?
175,000 even.
Right? So what happens is this. If you take 8% and times that by 175, right? This will pay out. this is the interest earned on 8%, at 8% on 175. So forever and ever, right? When I say forever, forever is a long time, that the school will receive this amount of money on a yearly basis. That's what this means, right? When they endow when the school receive an endowment, that's what this means. And this happens all the time. And I'll tell you something else. When you are a bank or a bank or a financial institution, you love things like this because you get to use this 175, oh my God, over and over, and all you have to do is pay out $14,000 to Queens College on a yearly basis. Yet you're probably making a lot more than this at even a much higher percentage, right? Than receiving only 14 grand. So these things are good. Institutions love these things. Okay, so it says right here, you want to endow a scholarship that will pay $11,000 per year forever, starting 1 year from now. If the school endowment discount is 4%, what amount you must donate to endow the scholarship? How would your answer change if you endow it now, but make the first award to a student 10 years from today? Okay, so let's first figure out how much this is in the first case, the amount you must donate today, right? So we're going to say 11,000, right? Cash divided by rate. So the cash amount is 11,000, and then we divide it by the rate of 0.04. And how much is that, class?
275,000 even.
Right? Now, when you're making this calculation, it says, how would my answer change if I endow it now, but I make the first award 10 years from now? So I need to know the present value of 275 going 9 years, because it starts from 0, right? It starts from 0. So 0 is actually 1. So what we need to do is take our calculator, right? And we're going to say, we're going to take, what's the present value? Present value of 275, right? Going back 9 years at 4%. And everybody should know how to do this by now. What's the present value? Somebody else. I want to hear from other people.
193 to 11.35. Is that right?
Good job. Good. Good. I want everybody involved. Good. Good. So if he decides that he's going to give this amount today, and then 9 years from now, it'll be worth this, and they can start paying this amount, this 11,000, forever. Because 4% of 275 is 11 grand per year. So the formula looks something like this. But we do it on the calculator to avoid mistakes. Good. Good. Yes,
So why is it to the 9th power and not to the 10th power if it's 10 years?
because when you're calculating these things, right, it says the perpetuity, right, you start from 0 in year 9, start from 0. If you were to do it on a timeline, not from 1, okay?
If we start from 0, wouldn't it be 10 years?
No, 0 to 9. 0 to, right.
Oh,
Zero.
okay.
All right. Okay. So when today I was looking at this question, and a lot of times with lottery winners, right, and they're going to receive a sum of money, but it's not for 74 years. It doesn't really work that way. I think there's a cap of 20 or 25. And he's supposed to be receiving $10,000 a year, right? And he wants to sell it. He wants to get all his money up front from like JG Wentworth or one of those companies, right? So what they do is they calculate the present value of your payments, right? And then they give you 75 cents on the dollar, something like that. So what we're going to do here is calculate, right, the present value of receiving $10,000 for the next 74 years at 10%. And what do you get?
So that's 99,931.51.
Good. 99931
913.
913.
How do you put this in the calculator again?
I
Because
will.
we don't
I'll show
have
you.
we don't have future.
913. Spot what? I can't see that. You got to tell me.
51 cents.
Okay. Point 51.
Yeah, 0.51.
Good, guys. Good. Okay, so on the calculator, it'll be like this. N equals 74. IY equals 10. Payment equals 10,000. Future value is 0. And present and compute for present value.
Why is future value 0? Aren't we getting paid 10,000?
No, no. What does it say right here? What does it say here?
Present value.
That's it. We can't make up rules.
Wait, so you're saying because it says present value, we're paying the 10,000 at the end of each year?
It says the value of it. Now, each time paid at the end of each of the next 74 years, right? So what we're doing is we're calculating. It looks something like this. 74, 10, the payment, 0, future value is 0, and the 99,913 spot 51. Now, if the question was the future value, then this number would have been way up. Over here. But that's not what they want to do. That's what they want to know. Right? Each payment going out 74 years, if you take 10 grand going out, let's say 74 years, just 10, right? One, it'll be like almost $1,000 or maybe even less, right? Each time each time you go further out, the amount gets less and less and less. Okay. A lot of people had issues with this, and a lot of people didn't. Right? Now, this has every function on the calculator that we use. Okay, every function. Remember this question. This question has every function that we use on the calculator, and this is it's a question that we calculate a retirement, right? But also there's some little quirky questions here and there, but that can really happen, right? That can really happen. So the first thing is that we're going to calculate the first part of the answer, right? And the first part is saying you're trying to decide how much to save for your retirement. Assume you plan to save $5,000 per year with the first investment made 1 year from now. You think you can earn 10.5% per year on your investment and plan to retire in 34 years, immediately after making your last $5,000 investment. So right away, I know that that I have to figure out that I know that the number of periods here is 34, right? And I know that my interest, my IY, is 10.5. And I know that my payment is 5,000, right? And I know that I don't want to know the present value. I want to know the future value, right? So present value is 0, and then I compute for future value, right? And then that's my first part of this answer. So what did you guys get? Anybody?
1,371,000.
1 million what?
371,
Mm-hmm.
759, 24 cents.
Good. Now, the second part of the question is if I had the money, if I had a lump sum, meaning maybe I had money saved up or I received money from an inheritance, right? How much money do I need to give you a present value of an amount? Now, there's two ways of doing this. Two ways of doing this, right? We can use the amount and calculate for present value, or which I like to do, take the amount that we have there, 1,371,759.24, and do a present value with that amount, right? So in this situation, you're going to say n equals 34, IY equals 10.5, right? Payment is 0. Payment is 0. You can do it, right? Payment is 0. And then we're going to say future values, 1,371,759.24, and then we compute for the present value.
So the answer is 46,021.47.
46,021.47.
0.47. Yeah.
Now, there's two ways of doing this. The reason why I don't recommend the other way, where you can go in and say n equals 34, IY equals 10.5, payment is 5,000, right? Future value is 0, compute for present value. You could do it that way. But let's keep it uniform. Right? You could do it that way. Now, one of the things that happens, right, in retirement right? Some people like to draw on their money, especially if they don't, they feel that I'm going to enjoy, right? I'm going to enjoy. So this person says, if you hope to live for 25 years in retirement, how much can you withdraw every year in retirement, starting 1 year from after retirement? So you will exhaust your savings with 25, with the 25th withdrawal, right? So here, right, we're calculating for payment. We're calculating for payment, and the number of payments is going to be 25, right? The number of periods, is going to be 25. IY is going to be 10.5. Future value is going to be 0, and your present value is going to be 1,371,759.24. And then I'm going to compute for payment, right? So that's what we're doing here.
$156,969.48.
Good job. Good job. So what this means is that if I take out 20, I will receive 25 times this amount, right? After retirement, if I decide to take the money all at one time, right? Every function is being used now. Now, here's another one now. This one is saying, I'm deciding to withdraw. Now I'm solving for number of periods. Number of periods now. That's what I'm resolving for, right? I'm saying that I'm leaving n alone, number of periods, because that's what I need to know. And that's what this question does, right? It attacks every part of this calculator that we used. So n, we're going to leave alone. And then the interest is 10.5. Now, remember what I said. When we have payment and present value going in the calculation, one of them has to be negative. So the payment is going to be negative 274. The future value is 0, and the present value is going to be 1,371,759.24. And then we compute for n. We compute for n.
Yeah, it's gonna be 25.
What'd you get?
25.
I can't hear that.
25.
No.
No?
I can't hear the answer.
It's going to be 7.47.
Yeah, I got 7.47. Also.
Wait, so is the payment supposed to be negative or no?
Yes.
Okay.
Yes.
Can you hear the inputs one more
So
time?
when you're paying off the loan, that's when the payment is negative. If you're getting the interest, that's when the payment is positive.
I can't hear you. Hold on 1 second. Who saw Michelle? Yes, go ahead, Michelle.
So when the payment's negative when we're like paying the loan, and if we're getting the interest, that's a positive payment.
Mm-mm. when you have two things going on at the same time. When we have our present value, right, and we have our payment. So they both can be going in the same direction. The payment is drawing from the present value. Do you understand that? The payment is drawing from the present value. This amount, hold on, let me finish. This amount, this 274, is being subtracted from this. So it can't be going in the same direction. So this becomes a negative when you put it in the calculator. Let's finish and I'll show you on the calculator. Hold on. So now the other part of the question, again, we're going to use negative with payment. This is calculating your rate of return. This is calculating your rate of return, right? So we're assuming, they said we're going to use the same numbers, right? And we're going to say n equals 34. And we leave IY alone, because that's what we're computing for. Payment is negative 1,000. That's what we're paying. Payment is negative 1,000. Present value is 0. And the future value is 1 million. And then I compute for IY.
I think it's 16.15.
Oh, yeah. Oh, yeah. All right, now let's look at it here. And this is how it looks. They can't be going in the same direction. This is being drawn from here to get this. Also, this, right, we're multiplying to get this number based on these equations. So they both can't be going in the same direction, right? Everybody okay with this? Stop me, as I said before, if you don't get it, so that way we can go over it, and you're going to see this question again. So that way we can definitely attack it. And we're going to go over this again. All right, let's move on. Okay, so this right here is a rich relative has bequeathed you a growing perpetuity. So growing perpetuity means that it grows based on the interest rate, right? So the growing perpetuity is cash divided by rate minus growth, right? That's how we're going to calculate this. So in this situation, it's going to be, the interest rate is 9% minus 8, so it's 1%. So 1,000 over 0.01.
10,000.
Okay.
It's 100,000.
Yeah,
Oh.
100,000.
100,000.
Okay, good. Now, let me show you the other part of the formula. Since it's growing, this is a growing perpetuity, but it grows bigger every time it pays out, right? So what you have to do is this right here. So you're going to say 1,000 times 1.08 divided by 9 minus 8, right? So now the following year, this is going to have an exponent of 2 because it keeps growing. Remember, it says the anniversary of the last payment, that is 8% larger than the last payment, right? So each year this gets bigger. And the calculation now, right? So forever. So this now you're going to say square. This is year 2, year 3, Q, 3, 4, 5, and so on. And each time this gets bigger. And also the payout, right, gets bigger.
Excuse me, Professor.
Hmm.
Yeah, so we will be asked only for 1 year in like in the
Yeah,
exam. No,
that's what we're doing. Only 1 year. Now, if
not
it would have said, if the question would have been, what would be the value of this growing perpetuity going out 2 years, then this would have been 108 squared. But it's not asking you that. It's asking you for 1 year. So the answer is 108. See, a lot of times what happens, what I always see on the exam, what people do is that they say 1,000 times 0.09. That's not the answer. This is what they're asking you right here, this amount, 8% larger than the last payment, right? And remember this formula. This is the growing perpetuity formula. You should have it on your sheet, right? And this is for the second part, right? A growing, right? Growing perpetuity, the present value of it. Any questions here?
Wait, so what's different between the first and the second parts formulas again? Like, was it just a slight difference of the second one had 1.08 on the
Yeah.
top?
The second one had the growing part, this part, that this part doesn't have.
Got it. Thank you.
Okay. Okay. So you have an investment account that started out with 1,000 10 years ago, which is now has grown to 9,000. So I'll let you guys do this one. Now remember what I said about the negative. That's a hint. All right, now you have to calculate. It says right here your annual interest rate. So what do I do? Tell me what the answer is.
Is it 24.57 for this?
The rate of return?
Oh wait, give me a sec. I think.
That's what you're calculating here, the rate of return.
I think that's.
24.57.
That much?
Yeah,
Really?
that, I think,
Okay.
unless I'm bugging out.
If you say so. Good. All right. Now, next part. This is where everybody messes up.
Is it 33,364?
33264. Now you gotta give me some sense there.
33.
0.33?
I think it's 33365.
Wait a minute. Let's start over. 33365.
Yeah, that's it. Because it was 364.
4.99 or
But it
No, it
99.
should
What's the
be
nearest cent?
364.99.
But we have to round to the nearest. Oh, okay, fine.
Good.
What would payment be? Because I didn't really put anything in for payment.
There is no payment here. There are
Just
no
put the
payments.
wrong answer. All of our stuff.
Right? This one is saying that you have an investment account that started with 1,000 10 years ago and now has grown to 9,000. So I know that I walked into a bank or whatever it was, a financial institution, and I handed this person $1,000. So I know that's a negative because I'm out the money. And now I know that the future value of it is 9,000. So the present value is 1,000 negative, and the future value is 9,000 positive, right? And then I know that the number of periods is 10, right? I know the number of periods is 10. And so, and then I calculate, and their payments is 0 also. There are no payments here. And then I calculate for IY. And this is an astronomical amount, right? Which is 24%. I don't know where you're going to get that from. That's why I was a bit amazed. But and that's what you're calculating for, the rate of return. The second part of the question asks you if you had, it says that if the investment account earns 14% per year from now, what would the account value be 10 years from now? So we already know what it has grown to. So now we do the same thing going forward. Now I want to know the future value of this 9,000 going out 10 years, right? And that's what we got here, right? So we know that N equals 10, IY equals 14, my payment is 0, present value is 9,000, and then compute for future value. And then we come up with 33,364.99.
So to confirm when the money's coming out of your pocket, it's gonna be negative.
What'd you say, Michelle?
Like just confirming, you said when the money's like coming out of your pocket, it's negative, right? Or
Absolutely.
okay.
Absolutely, 100%. We're losing, right? Absolutely, 100%. Now, keep in mind that in when you're doing this, right? Like right here, same thing. right here. I can't stress it enough. Now, one of the things too that when you work at an institution, as I said before, these numbers, the reason why we make them small in this class is so that they're manageable. But if you were working at a institution, Citibank, JP Morgan, Goldman Sachs, whatever the institution is, these numbers will be like 100 million and, 350 million, 70 million, 80 million, 90 million, all these numbers would change because those are the kind of numbers you'd be dealing with, right? Here we're dealing with small numbers because we want to make it manageable, right? When we work at an institution, oh my God, those numbers are large. Okay, so here, this question is a lot of times people that are wealthy do this. I say this all the time. They pay their mortgage once a year and they're done with it. So this mortgage has a yearly interest. Going forward, the mortgage that we're going to see, the interest we're going to see for mortgages are monthly, right? So there's a different calculation when you do the monthly than you do the yearly, right? Yearly goes in the way it is. Monthly, if this was a monthly mortgage, I would say 5 divided by 12. And that's what I enter. I would say 5 divided by 12, and the answer I get, I will enter that in my IY. But in this situation, this is a yearly mortgage. So I'm putting $57,000 down, and then I'm financing the rest, right? So figure it out. Help me out here, guys. So remember, 57 comes out of my principal amount here. So you guys got the rest.
22,3.
22
312.64.
and 12 point.
1,3 is the nearest.
Nearest dollar,
Nearest dollar, yeah.
13, right? 313. Good job. So it'll look something like this. And that's it. Now, if we were dealing, as I said before, if we were dealing with, excuse me, if we were dealing with a monthly mortgage, this will be 5 divided by 12, and this will be 360. This has to reflect this. This gets converted into months. So 30, right? 30 times 12 months becomes 360, and this has to reflect the monthly interest if we were doing a monthly interest. But since it's yearly, we keep it as is.
I'm sorry, Professor, can you say about a monthly, how to do?
Yeah. Sometimes when you buy a house, you're paying every year, the mortgage, right? Let's say it's January 1st and you're paying your mortgage, but you don't have to pay any more. That's it. Every year for 30 years, you pay $22,000, 313, right? Now, if this was a monthly mortgage, right? We have to convert this interest rate to a monthly rate, and we have to convert this period to a monthly period. So 30 times 12, which is 12 months, is 360, 360 months. That's how many months are in 30 years. And whatever 5 divided by 12, right, 5, hold on, 5.
0.42.
All right, 0.4116. So you go out 6 places. That's what the interest rate would be here on a monthly basis. Okay? And we're going to do that for cars. We're going to do that for motorcycles, for lease cars, and all of that. We have to reflect it so they're the same. That way you get the right answer. So when you go buy a house, you'll be able, you bring your calculator with you, you'll be able to calculate your monthly payments right along with the banker. And you'll know if it's right or wrong. You'll know how to do that when you calculate your own mortgage. You'll know how to calculate a car lease payment. You're going to know that too when you're done with this class. All right. Here, it says you're saving for retirement to live comfortably. You decide that you will need $3 million by the time you're 65. Today is your 24th birthday, and you decide starting today and continue on every birthday up to including the 65th that you'll be putting the same amount into savings. If the interest rate is 3%, how much you set aside each year to make sure that you will have $3 million in the account on your 61st birthday, right? 65th birthday. Now listen to me. I told you about this before. So when we say 24, we're subtracting 24 from 65, that equals 41, right? And we want to make equal payments. So we have to add 1 to the 41, and we make it 42. Okay? So take it from there.
What do you mean equal
And-
payments again? Sorry.
I'll explain it in a second, right? We want to make 42 equal payments, not 41. 41 is an odd number. So go ahead and give
I
me
think
the
it's
calculation for payment.
36,575.
How much?
36,575.02.
It should be round, no?
No, she's
To the
good.
nearest dollar. It took. All right. But let me show you on the calculator. It says right here, if we pay out, we need to pay $892 to have $3 million, right, in 41 years. If we don't have $892 today, we can make 42 equal payments. We want to make 42 equal payments. And that's why we're going to do it at 42. And also the annuity, another thing I always say with the annuity is set to equal 1, right, as opposed to ordinary annuity. That's another thing too. A lot of times the logic that I was told and explained that if I'm turning 65 and I'm due to receive this amount, right? And my birthday my birthday is not till December and it's January, right? Do I have to wait like a whole year to get paid, or do I get it when I turn 65? So that could be the logic behind that. Right? If you have an early birthday, then it's good. That's why they always tell you that the year that you turn 65, you're eligible. So there might be some logic behind that.
Professor, if the number, I'm sorry.
Go ahead.
If
Go
the
ahead, Rosa.
if the number of years is even, then we do not add the 1 to it. We leave it as is. This is only
Right.
when it's odd.
Right. And basically, so far as I've seen, it's always odd. A lot of people get this question wrong on the exam. A lot of people.
Professor, I have a question.
I have an answer. I thought.
Yeah. I was trying actually some example, and it was not coming right. If I tell you, can you like just help me? Why? Instead of it's saying that 65 by the age of 65 is going to retire, and today is 29.
No, 24.
No, that's what the question was saying. 29. So, and it's
Which
10%.
one? You had a question?
No, there was an example. There was an
Okay.
example. So I was just trying another example, but it was not coming right. And N is like 65 minus 29, so it's 36. IY is 10%. And then the future value is 4 million. So my answer was coming 13,372.
Where'd you see this? Where are you getting this from?
So it was in the example. Like
I have to, because I'm losing a step that you're talking about. When I see it, I'll understand. Do you have it? Can you email it to me?
all right, okay,
Email it to me. Let me look at it.
okay,
Because there's a step there that's being missed.
okay,
Okay?
all right,
All right.
all right, okay. I will. Sure, thank you.
Okay. So here,
Professor,
yes, my dear.
I'm sorry. The reason I asked is because on my example, it's 65, and today's your 35th birthday, which gives you even number 30. But when you put 30, the answer was incorrect. You had to add the 1 and make it a 31.
Right. And as I said, right, it tells you right here to add the 1 for the annuity, right, as opposed to ordinary annuity. And the logic behind that, right, sometimes is that, as I explained, that the way they calculate it, like for you, well, let's say, Rosa, you're going to be 30 years old, right, and you're due to receive a trust, right, and your birthday is not till December. They might say the year that you turn 30, you're eligible for it. So they just add that 1, so they make it where you get it on your birthday. Do you understand?
Yes. So whatever that difference is, you're always going to add the 1 for the annuity.
Right,
It doesn't matter if it's even or odd.
right, right. Based on, and you know what's funny? I'm going to tell you something, right? I learned something, or every time, every semester, I learn something new, right? We had this question. I remember I was talking to someone, and the question was, we were trying to calculate an annuity, and we had a guy that used to do them in the class. That was his thing. And he was explaining that about the birthdays and all that. And I said it made sense, but I didn't know if that was right. But then it makes sense because sometimes there's some things that pay out on the year that your birthday is. right? Imagine I'm waiting on some money, and especially me, because my birthday's in November. So you mean to tell me I gotta wait 11 months for this to happen, right? So good point. Good. So the logic is to add 1. And please don't come to me after the exam if this was on the test where you said. I just said it. So here, what we're going to do is cash, right, divided by payment. Right? I'm sorry. Payment divided by cash. And then we'll figure out how much the rate of return is. Now, what this is, you put $5,000 in the bank at 6%. And each year, they send you a $300 check forever. Right? Forever. It does not compound, none of that. They send you the check. And all you do is keep the money in there. Now, believe it or not, we used to have something in Citibank called rollover. Rollover is where the banks or the different institutions deposit like 5 million or 10 million, 20 million, whatever it is, from deposit at Citibank. And what happens is that every day, because I used to deal in Treasury in the Fed funds, every day it would pay out an interest based on an interest rate that's calculated. It could be a LIBOR, London Bank offered rate. It could be a FTSE, whatever it is, the rate was, and that's the rate that they use. And each day, they will send that customer that amount of money. And this is the same exact thing, but this is on a yearly basis. Since I dealt with overnight Fed funds, right, it was given out on a daily basis, right? And it was done. Oh man, and it was, and the bank, if the bank is giving you 5%, believe me, they're making 8 or 10, right? If they're giving you that kind of percentage, they're making a lot more so they can pay you. And then it was crazy. It was like a money machine. And some of these banks were in small banks, right? Very small. And $1 million or $2 million was probably all they had in total, because it's like a small bank in a small town. And they would send that money and have it in New York, and they would earn interest on a daily basis. It was good for them. What did we get? What was this, 6%? Yeah. Okay. I wanted to, there was a question that I saw. I don't like to send you guys to war. There was a question, I assigned the quiz. There was a question that I saw in the quiz that we did not go over, a couple of them. One of them is a tricky question, and I wanted to go over that before I assigned it. One question before I assign the quiz. So let's preview it. Okay. this question, please learn this question. There's a function on the calculator that you can do this, but I don't recommend it because if you make one mistake, this is wrong, then this is going to be wrong, right? So it makes sense for you just to take your time and calculate each value. It takes less than 20 seconds or 30 seconds, whatever it is, to calculate each value, right? So you've just received a windfall from an investment you've made in a friend's business. She will be paying you $16,688 at the end of this year, $33,376 at the end of next year, and $50,064 at the end of the third year. The interest is 12.9%. What is the present value of your windfall, right? So you need to take the present value for each one. This one going out 1 year, this one going out 2 years, and this one going out 3 years. Then you add them together, then you put them right here. After you do that, you get this number right here, then you say, you calculate the future value of it going out 3 years, and that's the number you put here. So let's try that together. So let's calculate the present value for $16,688 going out 1 year, the present value of $33,376 going out 2 years, and the present value of $50,004 going out 3 years at 12.9. Do each one. I'm telling you, that way you won't mess it up. So give me that, and then we will end the class with that.
How big is the number supposed to be?
I don't know. If you take the present value of 16 and 33, what did you get?
But I only got it for the first year. Just give me a second.
Okay, so that's 1. You got to do it for 2 and 3.
You said you get all three and then you add them together?
Right, after you get the present value. This for 1 year, this for 2 years, and this is for 3. What'd you get?
I got 22,467,
22,000?
22,468 because it's asking you to.
No, that can't be right. $16,000 going out 1 year is about 15 grand. 33,000 going out 2 years, that's about maybe 29. 50,000 going out 3 years, that's about 47. So that can't be right.
It's going to be 88686.
88?
686.
Okay. Now, give me the future value of this number going out 3 years.
So I think that's 127,625.
Both wrong.
I have a different number for A.
Okay, go ahead.
I think it's 75,755.
Okay? That part is right. Now give me the second part, the future value.
109,017.
Oh, yeah. All right. Everybody got that?
Can you go over it one more time?
Yup. You're going to say, I'm just going to tell you, for the first one, you're going to say n equals 1, and you get the present value of 16,000. So this is what you, n equals 1, IY equals 12.9, payment is 0, future value is 16,688, and compute for present value. That's the first answer. Second one, n equals 2, IY equals 12.9, payment is 0, future value is 33,376, compute for present value. That's 2 years. Third one, n equals 3, IY equals 12.9, payment is 0, future value is 50,064, compute for present value. Add all three values together, you get 75,755. Then you want to know the future value of this amount. So n equals 3, IY equals 12.9, payment is 0, present value 75,755, compute for future value, and that's your amount right here.
Okay, thank you.
All right. Hold on 1 second. All right. Okay. I'll see you guys on Tuesday. I assigned the quiz. And after we're done with that, we'll start reviewing for our midterm. Okay?
Hi, Professor.
All right. Take care.
Wait, so what's the date gonna be for the midterm again?
I don't know yet. Okay.
Thanks, Professor. Have a great night.
Good night, Professor.
Take care. Take care. Good class.
Good night. Bye-bye.
Goodbye. All right.
Yeah, thank you. I really enjoyed Professor.
All right. Thank you. Okay.